Hello, welcome to this lesson on derivatives of logarithms, exponential and trigonometric functions. This is ITE 1812 Mathematics for IT. We will first look at the learning outcomes. So by the end of this lesson, you should be able to apply differentiation rules in order to find the derivatives of logarithmic, exponential and trigonometric functions. We will first look at the derivatives of logarithmic and exponential functions. So first, taking a look at the derivative of natural logarithm, which is denoted by ln of x. So d over dx ln x will be equal to 1 over x. So this is the defined derivative of the natural logarithm. So which is an important concept when you move forward with differentiating functions and combinations of functions. So for example, if we take d over dx 3 times ln x, you can take the constant in front and then apply the derivative of the natural logarithm derivative of ln x, which will be 1 over x. So the eventual answer for part A in example would be 3 over x. Part B, you have d over dx x times ln x. Then you apply the product rule. Derivative of x times ln x and x times derivative of ln x. So that becomes ln x plus x times 1 over x, which is 1. So the eventual answer would become 1 plus ln x. Now, that was previously we discussed about the derivative of natural logarithm. So now we generalize that to any base. So for base b, we shall define the derivative of the logarithm with base b. So for example, we have d over dx log to the base b x, log x with base b will be equal to 1 over x times ln b. So this is the definition of derivative of a logarithm with base b. Going into some examples, part A, d over dx log x to the base 3 will become 1 over x times ln 3, which you can simplify. It will become 1 over 1.0986 times x. And similar function, you have in example part B, d over dx log to the base 2 x to the power 4. Then what you have to do? You have to take d over dx 4 times log to the power 2 x, and it will become, the constant will come forward 4 times 1 over x ln 2, and it will simplify to 4 over 0.6931 x. So this is how you get the derivatives for logarithms with base b. So you can do that for any base using this. Now we identify the derivative of exponential functions, specifically ex. D over dx e to the power x would be equal to e to the power x. It's a very important definition. So we'll take some examples. In part A, you have d over dx 3 times ex. That will become, you can take the constant in front, 3 times d over dx e to the power x, which will eventually become 3 times e to the power x. And in part B, let's take d over dx ex over x, and then you have to apply the quotient rule to simplify this derivative. When you apply the quotient rule, you will see that you get e to the power x times x minus 1 over x squared. So the new concept that we introduce here would be the derivative defined for exponential function ex. And now we will introduce some simple definitions for trigonometric functions, the derivatives of trigonometric functions. So first, take sine function. D over dx sine x is defined as cos x. Take an example. We are asked to differentiate the function y, which is sine x squared plus 3. So let's take x squared plus 3 as u, and y will be equal to sine u. Then you can apply the chain rule for differentiation. So dy over dx is equal to dy over du times du over dx. So dy over du becomes cos u because the derivative of the sine function would be cos. Then you have cos u times du over dx. So u is defined as, we know that, x squared plus 3. So what you have to do is, so cos u is cos x squared plus 3, and the derivative of u with respect to x would become 2x, because there's a constant 3 which will become 0, and x squared will become 2x. The derivative of x squared will become 2x. So eventually you are left with 2x times cos x squared plus 3. So this is how you apply the different rules, and now the newly obtained knowledge about trigonometric functions, the derivatives of trigonometric functions. The next one is the cosine function. So the derivative of cos x is equal to negative sine x. So we will apply this in an example. We are asked to differentiate y, which is cos 3x to the power 4. So we will see how we do this. So let u become 3 times x to the power 4, then y is equal to cos u. So once again, you can apply the chain rule, dy over dx. That's the thing we need to find out. And then it can be written as dy over du times du over dx. So dy over du will become negative sine u, because that's by definition the derivative of the cosine function. And then you have to take du over dx. So negative sine u is negative sine 3x to the power 4. And when you differentiate 3 times x to the power 4 with respect to x, you will get 12x cubed, right? So eventual answer would be negative 12x cubed times sine 3x to the power 4. So this is how we apply. In this case, you apply the chain rule and you used the derivative of the cosine function. So now we have the tan function, the tangent function. So d over dx tan x is equal to sec squared x. So let's take an example once again. So differentiate x tan x. So we need to apply the product rule here, product rule of differentiation. So here you want to get dy over dx, and you apply the product rule. It becomes x times sec squared x. Why do we have sec squared x here? Because that is the derivative of tan x. And then plus tan x times the derivative of x with respect to x, which will become 1. So eventually you have x times sec squared x plus tan x. So that's a simple example of using the derivative of the tangent and applying the product rule of differentiation. That brings us to the end of this short lesson. We introduced the derivative of logarithms, exponential and trigonometric functions in this lesson. So you can try more examples to get more practice. In the next lesson, we will be covering integration. We will introduce the concepts of integration. Thank you.